Hello. So my name is Michael Haigh. I'm a technical marketing engineer at Nutanix. In my day-to-day job, I get to speak with Nutanix customers or potential customers and create technical content for some of our cloud native and automation products. So I appreciate you coming to Staying Calm While Being Eaten by a Unicorn. Title should make sense, hopefully by the end of the talk here. So before we get started, let's do a brief overview of what I'm going to be discussing today. So I'll talk about my company, Nutanix, so you get a feel for what we do. And then also, I'll be talking about the company that we acquired a couple years back, Calm.io. Next, I'll talk about how we integrated the product, or our products together, and then the architectural decisions that we made to help enable us achieve DevOps outcomes. And then since the acquisition and the release of the new product, how Calm has influenced the rest of Nutanix. And then depending on the amount of time we have, I'll talk a bit about how Nutanix customers implement DevOps. And we'll definitely finish it up with our top lessons learned. All right, so if you don't know about Nutanix, we pioneered hyper-converged infrastructure in 2009. So it's essentially converging your compute, storage, and virtualization down into one platform to give you the agility and simplicity of the public cloud in your own private data center. So we're also very committed to customer choice, whether that's hardware options, hypervisor options, consumption models, you name it. So our mission is to make data center infrastructure invisible, elevating IT to focus on the applications and services. So we were founded in 2009. We have over 12,000 customers currently, almost 5,000 employees. And in 2016, we went public with a valuation of about $2.2 billion at that time, officially making us a unicorn. So how do we do? I won't spend too much time on this, but how do we actually make the data center invisible and allow our customers to focus on the applications rather than the infrastructure? So you'll see the slide. Traditional data centers, you'll have your storage array, you'll have your compute with a virtualization or a hypervisor on top of it, and then a complex storage area network in the middle. So to provision a new application, it often has to go between 3 or 4 different teams. Hand off, and we all know that is not ideal. So rather than having that sort of architecture, Nutanix essentially converges all 3 of those things down into one platform. So we take software and allow the local attached disk drives on the servers to get aggregated into one large storage pool and essentially virtualize the storage controller. So now rather than managing 3 or 4 different components in your data center, you have a single pane of glass to manage your data center. And all it's required is a top-of-rack 10-gig switch. And these clusters scale really well as your demand or your needs grow. So we also have, as I mentioned, a single pane of glass for management. So this is Nutanix Prism, essentially allowing you to manage your compute, your virtualization, your storage, all from that single UI. And this will come into play in just a little bit. We also have a product called Prism Central. This, when you grow outside of a single Nutanix cluster, whether that's several in a data center or several scattered across the world, we have a product called Prism Central, which allows you to manage all of these clusters, again, from that single UI. So switching gears a little bit, let's talk about Calm.io. This is the company that Nutanix acquired in 2016, just before our IPO. They were also founded in 2009. However, they're much smaller, with only about 35 employees at the time of acquisition. And their mission was to enable enterprises to achieve DevOps outcomes through hybrid cloud application, lifecycle management, and automation. So what does that mean exactly? Here's a screenshot of what we kind of internally refer to as old Calm, the pre-integration version of Calm. So this is an application blueprint. So you can model your bare metal, VM, or container-based applications in a blueprint, which allows various teams within your company to collaborate on that blueprint, depending on which team they're on. You can then launch that blueprint onto any of the public clouds or your on-prem data center, and then manage that application throughout its entire life cycle. And then also we have it has an integrated self-service portal to enable your end users to go in and deploy and manage their own applications, all while adhering to IT governance and quotas and budgets. So obviously, third day of the conference, hopefully the terms of automation, governance, self-service are pretty familiar to you. So Calm.io was a platform essentially to help enable our customers achieve DevOps outcomes. But not only that, Calm internally was a very DevOps heavy shop. So the Calm software was microservice architectured. They performed extensive continuous integration and automated testing. And they also use Calm internally to enable their own developers for self-service. So Nutanix was really fortunate. I don't know that we realized at the time how fortunate we were to acquire a company that had been living and breathing DevOps for years and years. So as I mentioned, in 2016, we made that acquisition. But we had some difficult choices. So I've been talking about how Nutanix has this single pane of glass, right? So you have Prism Central, which is managing your entire data center infrastructure around the world. But now we have a new product. We could certainly opt for speed to market, do a simple rebranding of the Calm software, and release it. But we kind of just then lost a lot of our benefits of having that one pane of glass. Alternatively, if we did integrate the two, how could we make it so the Calm.io team that we just acquired doesn't lose all of their proven DevOps methodologies that they've been implementing for years and years? And also, if we did integrate it, how it would take quite a bit of time. We actually did make that decision to integrate it natively. It took us about 16 months to rewrite the software, and we were fortunate enough to be able to take that time and rewrite most of the Calm software and integrate it natively within Prism Central. So how does that look? And what sort of decisions did we make to be able to help keep Calm's DevOps roots? So as I mentioned, Prism Central is our multi-cluster manager. It could be deployed as a single virtual machine or scaled out to multiple virtual machines for redundancy, but it is still more or less your traditional monolithic application. So what we decided to do was run the Calm software as a couple of Docker containers within Prism Central. So this allowed for a variety of things like independent releases, microservice architecture that we're going to talk about. So how successful has this been? We released new Prism Central software every 3 to 4 months, which at this conference might sound like a while. I do want to note, we're providing infrastructure for large enterprises like banks and hospitals. So those sort of corporations cannot generally upgrade, every week or every day. And stability is crucial. But the success of Calm and how the architectural decisions and how the team is run has allowed the Calm team to release every 1 to 2 months. So 2 to 3 times faster. And how have we made this happen? So first up, we have a product called Lifecycle Manager in Prism Central. So this allows you to upgrade the various components of your Nutanix stack independently. So it could be disk or node firmware from a physical perspective. It could be the virtualized storage controller, or it could be Calm. So in this screenshot, you see we'll have an available Calm update, and all the end user has to do is select the Calm containers, click update, and it'll take about 10 minutes, and we'll refresh those Calm containers, all without affecting any of the rest of the software. We also make use of extensive microservices. So on the left, we have the Calm container. That's essentially the front end. It's made up of 4 microservices. And then the back end, the orchestration engine, which is Epsilon, is made up of 7 to 8 microservices. And we split up our teams in this manner to allow them to work on new features where they don't impact other teams or other microservices as long as they adhere to the published API requirements. And just a high-level overview, I won't spend much time here, but this is kind of a general workflow of launching a Calm application from an API perspective. So Calm interacts with Applos, which is the Prism Central API engine, and all the way through, everything is API-based from start to finish within Nutanix Calm. So the next up is from our team perspective and our new feature perspective. So if we have a new feature request in Calm, we essentially create an agile, small working team. Internally, we call it a pod. It's made up of a product manager, a UI engineer, a back-end engineer, and then a software development engineer and tests. So essentially a QA engineer. A new branch will be created off of our master branch and named appropriately according to our internal naming schema. That obviously release, depending on the feature, it might take a couple of hours, might take a couple of days, might take a couple of weeks. But however long it takes for all of the members of the pod to be in agreement that the code is in a good spot, we kick off something called we kick off a Fabricator code review. So if you guys haven't heard of Fabricator, it's a code review tool similar to Garrett. I know a lot of companies use Garrett. It was originally created by Facebook and then spun out. It's a really powerful tool. Definitely recommend looking into it. But the Fabricator code review has a lot of automation built into it. It does several things, including adding a Jenkins reviewer, and then also other members of the Calm team based on some predefined rules. So the Jenkins code review pipeline will get kicked off prior to any other member, any actual person reviewing the code. It takes about 3 hours to run through all of the automated tests. So there's a lot of unit tests at the beginning. They build all of the RPMs. They even build the containers. So if we see here, we'll build the new Calm and Epsilon containers. They will get placed in a test instance of that Prism Central, and then do a large amount of integration testing as well. So assuming all 3 hours worth of those automated testing is successful, then the rest of the actual people in that code review will have to sign off on that release. Once it's signed off, we'll merge it back into master in an automated fashion. And another different Jenkins repository pipeline is kicked off. It's going to look pretty similar from a screenshot perspective. The main difference being the Prism Central, so essentially the virtual machine, the monolithic app that I was talking to you guys about, is running master code. So the latest and greatest Prism Central code as well. So again, it's about 3 hours of automated tests. When successful, then everything is good. And if it's not successful, then we report back to the pod that creates that branch. And they can figure out what went wrong and take steps to remediate it. Okay, so switching gears, so let's talk about how Calm has influenced Nutanix. So I mentioned we were really fortunate to acquire a company like Calm. And to a certain extent, we just kind of had to get out of their way and allow them to do the things that they were doing really well. But since then, we've seen the success of the Calm software, the release model, and the testing model. So that is kind of influenced the rest of Nutanix. Pretty soon here, we're releasing a microservices platform built on Kubernetes to run all of our services. So we'll be slowly migrating services over. And we have a product called Nutanix Buckets, which is an S3 object storage solution that will be the first product to run on MSP. It should be released in about a month. We also have a customer-facing version of MSP called Nutanix Carbon. Essentially allows you to deploy Kubernetes clusters in your on-prem environment and then manage them throughout their entire life cycle. So that is also, like Calm, runs as Docker containers within Prism Central. So we've seen how well the container architecture works and allow for those independent upgrades. And lastly, we have a product called Xia IoT. If you guys were here for the lightning talks last night, my colleague Dave Hocking talked about implementing this using a Lego tool that sorts marbles. And so essentially it allows our customers to run containers at the edge at scale. All right, so let's spend a bit about time on how Nutanix customers implement DevOps. I don't want this to be a product pitch, so I'm going to be talking about competitors as well, just general things that we've seen that have worked well, whether it's with our products or with some competitors or public cloud providers. So obviously the core infrastructure, right? You need some sort of compute and virtualization, and then some sort of storage services. Doing this, whether it's in the public cloud or a private cloud in your own data center, is critical, but you need to have some sort of cloud-like functionality where you really can easily spin new workloads up and tear them down at will. So I mentioned buckets earlier, so object storage, if you guys haven't used object storage at all, like Amazon S3, is a fantastic way to provide storage to your Kubernetes-based applications or provide backup. It's massively scalable and works really simply with HTTP requests, so it's very friendly for developers. You can also use, for other Kubernetes workloads, most storage companies have something called a CSI driver, container storage interface. And so essentially that allows you to use block-based or file-based storage for your Kubernetes workloads in a persistent manner. For the more traditional backends, a database as a service product is hugely critical. So if you have developers that have to go and request to the database team for a new dev or test database, and they have to wait a week, we know that's not going to be very successful. So the ability to spin up new databases on the fly via API is hugely critical. So something like Amazon RDS or Aurora work really well. We have a product called Era that does a similar thing in your on-prem environment. And it also does some advanced copy data management. I mentioned Carbon already, so kind of a Kubernetes platform. So Kubernetes has a ton of advantages, but if you guys have ever run a team or if you yourself run Kubernetes, you know there's a lot of challenges involved as well between maintenance and upgrades, and just the general day two operations are often very difficult. So unless you're an enormous, behemoth company, some sort of managed offering like GKE or EKS is a great idea. So automation, I've been talking about how much we've used automation internally between Jenkins. We also use Calm internally. A lot of our customers also use Terraform, for instance, so you can stand up new Nutanix clusters or use Terraform to stand up new public cloud workloads. It's hugely critical. Again, we don't want to have our developers waiting around on our operations teams to stand up new environments. And lastly, some sort of application observability and monitoring tool is hugely critical. If you're switching over from a traditional application to a cloud-native application, you often can't use the same observability and monitoring tool. They're just not really built for the distributed nature of cloud-native apps. So I'm going to show a short video, which is I'll walk through, and we'll actually show off Nutanix Calm a little bit, and then just kind of show a general, let me advance the slide one more. This is the general workflow of what we'll see in the video. So this allows your developers, through automation, to just do a simple git commit and git push. And at the end of the 10 minutes or so, as the environment gets stood up, they'll have a fully functional application they can perform additional tests on, or ideally do automated testing. So let's take a look at how that works in action. So this is Nutanix, this is Prism Central, as I've been mentioning, our multi-cluster manager. And we'll go ahead and navigate down to the Calm section. So this is a list of our application blueprints. And we'll select a particular application blueprint that is using some of the products that I just mentioned. So first up, we're talking to Era. to provide that through APIs to provide a production-grade Postgres database. So the cool thing about Calm also is it deploys onto the public clouds. So if you are looking to have your end users be able to choose, do I want to deploy this on-prem or into AWS, for instance, you could build this same blueprint with a new application profile, and we could talk to RDS and call RDS APIs instead of Era. We're also tying into Nutanix buckets to store our images for our application. Again, that's our S3 compliant object storage solution. So something like Amazon S3 works really well. And then lastly, we have a containerized, essentially our web app. So this is, we'll see it in running momentarily. But it's built on Oscar, which Oscar is an open source e-commerce website. If you Google it, you'll see it. It's built on the Django Python framework. And so there's a deployment of 6 containers. You see their normal Kubernetes selectors and labels. And then finally, it's being exposed via a load balancer service on port 8000. So the next part, depending on time, we'll be able to see Epoch, perhaps not, but essentially Epoch's that application observability monitoring tool. And then we also have a load generator. So if you are subjecting this to automated testing, you probably want load on the application. So just to see a normal developer workflow, we'll do a git status, and we have a couple uncommitted changes, and then we'll do a git push. And so those are things your developers are doing every day. That's going to trigger the Jenkins build. And in this instance, we have a failure. We're going to get the fast feedback that Jenkins provides, which is fantastic. We're going to see I have a simple typo in my commit. And so we can go ahead and get, for instance, an RSS notification for a developer that our build failed. And we can very quickly and easily make that change while it's fresh in our minds. So we'll fix that, do another commit and push. And then this time we should see it build successfully. So what happens is Jenkins is going to do a lot of unit testing beforehand. If it builds a container successfully, get pushed to Docker Hub or an internal container registry. And then it will launch that Calm blueprint that we just went over. This will take about 10 minutes, so the video is going to fast forward. But we can do a full audit trail of exactly how that application is getting deployed and if it runs into any errors. Once it's actually running, now we have this application that our developers can test. We're going to go ahead and access the application in a second, and we'll see our new storefront. So this can then be subjected to further automated testing or manual testing. So we'll grab that IP and enter it in our web browser, and we'll see we have our e-commerce website with some Nutanix products. And we see that we have our new shop tagline built for DevOps Enterprise Summit. So I'm going to pause there. I'm ready to skip the Epoch portion from a time perspective. I would definitely want to leave plenty of time for our lessons learned here at Nutanix. So this is kind of in conjunction with the Calm CEO, who's now a general manager at Nutanix. He started out as a developer. He's been doing some sort of continuous integration and continuous development since the late 90s for a long time before kind of the rest of us have come around to this. And then also just from talking to customers day in, day out. So first up, in our opinion, your automated test suite coverage is absolutely critical, if not the most important thing. So these numbers are not, I don't want to say these are hard and fast rules. Everybody's environment's a little different. But anywhere between 60 and 70% of automated test coverage we feel is very good. Above 70% is absolutely excellent. And on that note, don't try for 90 plus 100% coverage. You're going to be spending all of your time actually, writing test cases and not developing new features. So really the only way to do this is require coverage at commit. So when I talked about the agile small pod earlier with the QA engineer, so they have to have their test cases written and done before that code can get checked in to merge to the master branch. If you say, hey, I'll get around to this tomorrow, tomorrow you're going to be working on some brand new feature and not actually get around to it. So if possible, from a code perspective, do not use multiple repositories. We often see our customers think, if I want to do microservices, then that means I have to do multiple repositories. It's ideally, it's not required to do multiple repositories for microservices, and avoid it if at all possible. There are certain cases where you have to do multiple repositories, but it's going to make your automation a good deal more difficult. So next, Kubernetes is a means to an end, right? But it is not required to do DevOps. You can certainly do DevOps through extensive automation in virtual machine or bare metal based instances as well. Automation is being the key. And then lastly, kind of similar in that vein, do not simply containerize. And so what I mean by that is don't take your monolithic application, containerize it and go run it via Docker or run it through Kubernetes and expect you're going to see some sort of savings, right? The true savings of containers comes through microservice-based architecture. So that requires often rewriting your application. So whether that's through an acquisition or a small new feature of your new product, then that's a great place to start. But again, don't just containerize your existing app and expect to see any efficiencies. We're supposed to finish with, here's what I'm looking for help with. This is more of a personal thing. I really want to learn Go. So if anyone is familiar with Go, I've never used it, and I know we're using it a lot more internally at Nutanix, so it's something on my to-do list. So if you have any recommendations as far as tutorials or any Go recommendations, let me know. Again, thank you for your time today. My name is Michael Haigh. I welcome feedback, so please come ask me any questions or provide any feedback. Thank you.